So we've done sine law, we've done cosine law, and people were pretty good at both of those, I think. Now we have to mix them together, and it's trickier than SOHCAHTOA trig in deciding what you have to use. Okay, so we want to know both formulas and both versions of both formulas. And I hope you wrote that down. Those are the conditions under which you use sine law and the conditions under which you use cosine law. Everybody is different in their approach to these questions, and the only way you can figure out how your brain works is by practicing a few questions and sort of seeing how it goes. And then if you're getting stuck or anything, you can obviously ask or talk to somebody else and see what they're doing. But everybody's a little bit different. So here's how it makes sense to me. I'll give you this as a starting point, and then as you're working, you can figure out what worked for you. The conditions for cosine law to me are very clear. Okay, it's always straightforward. Whereas sine law, there's those tricks where it gives you the wrong angle or something like that, right? But cosine law is always straightforward. So in my brain always just automatically looks to see if I'm using cosine law, and if I'm not, I know with 100% certainty that it's sine law. I don't have to second guess that. It might be a tricky sine law, but it's still sine law. So the conditions for cosine law, we talked about this yesterday, is if I'm given two side lengths and the contained angle. So in that case, I'd be searching for a side. That's what I can find. Okay, if I'm given two sides in the contained angle, I can find the third side, and I would use that top formula there. Or if I'm given all three sides, I can find any of the three angles, and I would use that formula to do that. If I don't have one of those two conditions, I'm using sine law. Whether it's the straightforward version or a tricky version, I'd be using sine law. That being said, sine law is also sometimes easy to spot. The learning goal we just took up, when you have a side length and an angle across from each other and any other piece of information, you're using sine law, right? But like the second one on the learning goal didn't quite have that, so it's a bit confusing. So some people think, oh, maybe it's cosine law, but it's not, right? So if you have two angles and any side, you're going to use sine law. You're going to find a side length, so you're going to use that one. Because if you have two angles, you actually have three angles. And so you'll have that pair of angle and side across from each other. And then the other condition is if you have two sides and then one angle, but the angle is across from one of the sides, then you're looking for an angle and you'd be using this one. If you think about it, two sides and the angle between them, or two sides and the angle across, are like the two sort of possibilities, right? You have two side lengths, you either have the angle between them or one of the other two angles, which is across from one of the two side lengths, right? So there's a lot of patterns happening there, a lot of ways that you can look at this, and that's why I say only you can figure out for yourself sort of how these questions speak to you. So let's take a look at a few of these. You don't write this down. We're just going to do this together. There's not really enough people to I was going to maybe have people work in pairs, but there's not really enough. So all I want you to do is look at that and decide, thinking about those conditions, which you're going to use. So here's how, again, we're not going to really solve it, but you would have to decide, am I using sine law or cosine law? And then which of the versions am I using for sine law or cosine law? So don't shout it out, but think about it for a moment. How many people already know? It's obvious, right? Sometimes it just kind of jumps out at you, right? And this is one of those moments where if you're sitting there and you say, I have no idea, well, guess. Force yourself to come up with a reason to make a guess. Ahmed, what do you think? Cosine law, why? How do you know it's not the sine law? Yeah, perfect. That's a great answer. And if it's not sine law, it has to be cosine law. That's a very good answer. The other answer that I would have accepted, somebody else help me out, Riley?
You have all three sides, and also you have two sides with an angle.
Well, I have all three sides. That's what I was looking for. two sides, I'm looking for the angle between. I don't know it, right? That's what that's talking about, those conditions. Two sides and the contained angle means it's given, like you know the angle. But you're right, cosine law, one of the conditions is that you're given all three sides. I should have been more clear about that. That this is the numbers that you're given. I'm given all three sides. That's when I use cosine law. So this is a cosine law question. I'm looking for an angle. So again, you don't write this down, but I would use this version. A squared plus b squared minus c squared over 2ab. What would I put in for c? 17.3 across from the thing that I'm looking for. Okay, lots going on there. Next one. Sine law or cosine law and why? Think about it. Mark? Why?
Because you're 34 and 43 and 76 and
So you have this pair of things that are across from each other, so you use sine law. And one other piece of information. And I can find theta directly. Very good. So you'd be using sine law. Another answer would be you can't use cosine law because you don't have all three sides and you don't have two sides and a contained angle. You have two sides and an angle across, right? So that's sine law. Very good. Next one. Sarah, what do you think? Why? And that's one of the conditions that we wrote out for sine law. Very, very good. This is the hard one, though. First of all, it's funny. Some people are very visual, and like everybody's different, right? What's obvious to some people, and we all are guilty of this once in a while, saying, "Oh, that's easy." It might be easy for you, but it's not easy for somebody else. Some people look at this and they think these two sides are across from each other. Sides can't be across from each other. Sides all in a triangle always touch. Doesn't matter which two sides you talk about, they always touch. They're not across from each other. But they kind of look that way because this is what I call like a wedge triangle. It's like skinny. And for some reason, or they think that these two angles are across from each other, but they're not, right? So it can really be confusing for some people if they have a hard time visualizing these things. It's very interesting. But so this can be one of the tricky ones. The reason why is because now I do have an angle and a side across from each other, but then I don't know the angle across from the side I'm looking for, but I have two angles, so I have three angles, so I can figure it out, right? It's like the one on the learning goal. But one of the conditions once two angles and any side will always be sine law. Okay, one more. Fiona, what do you think? Why would you say that? Very nice. Well said. Two sides and the angle between them. So it's cosine law. Try to use sine law and it won't work. If you're ever working on this stuff and like you might, even if you think you get this, once in a while you make a fumble and you pick the wrong one and something's not quite working, like something feels wrong, go back to the beginning because maybe you chose the wrong thing. If you tried to use sine law, you'd probably get partway through and be like, there's something weird about this. I don't know. I feel like I'm forcing something, right? But in this case, I would do c squared equals a squared plus b squared minus 2ab times the cosine of c. I hope you have that memorized, right? And c, the angle, is the 57, and a and b are the other two sides, right? So that's what you would do. Okay, so let's try a few of these. What we're actually doing today, though, is solving the triangle. We did this with SOHCAHTOA, and the way that we did it with SOHCAHTOA was we found all the information, right? So you're given three, you find the other three. Same thing goes for when we're doing this with non-right triangles. So let's take a crack at this. Still going to use our little summary here. A equals B equals C equals A equals B equals C equals. And I can fill in some of the information that I already know. So A is 80. Little c is 18.3. For some reason, we don't have units here. Little a is 21.2. So those are the ones I have. I have to find the other three. The difference between this and solving with SOHCAHTOA is solving with SOHCAHTOA, you can actually find anything at any time. So in your first step, you could find whatever you want. So you can't make the wrong answer. But in non-right triangles, there's only one thing I can find in this situation. I have to start in the right place. After that, you have some choice. But at first, you have to start in the right place. Okay? So that's part of figuring out, am I using sine law or am I using cosine law? And then you also have to decide, what can you find with sine law or cosine law? So anybody want to help us out here? Riley, what do you think?
For angles, you use sine law.
I can use, why is that?
Because, yeah, you have that pair that you just marked, and then you have 18.3.
So that's exactly how this works. I have two sides and not the contained angle, a different angle. So it's sine law. And what can I find? In this case, the thing across from 18.3. Okay, so let's go ahead and do that for C. I'm going to use sine law, so sine, again, this is the weird one, A over A equals sine B over B. We talked about this yesterday. If you don't like that, you could use the formula sine C over C equals sine A over A and just use the same variables. If you use different variables in the formula, you're not going to get marked wrong or lose marks or anything, so that would be fine. But this is weird because now I'm subbing C in for A. Sine of C over the side length across from it, 18.3. And I'm subbing A in for B, sine 80 over 21.2. I think that's a really good thing to understand. That means your brain is working abstractly the way we want it to, but it can be tricky for some people. Rearrange. And solve. I'm going to run out of room here. What do I have to remember when I'm putting this one into my calculator? Mark? Shift sign, right? Or second function. Yeah, it's okay to call it the second function. Yeah, exactly. And then what do we need to remember when we're solving is that, yes, we round, but remember, we sometimes need extra decimal places. So I got 58.2218. And the rule of thumb is if you keep 4 decimal places, you'll always be safe. And then I'm going to go ahead and put that in for C, but I'm going to round it to the nearest degree, because that's what we're supposed to do. Any questions about that? Okay, now what can I find? Why? Right, so it's easy to find B, so let's go ahead and do that. Good call. Once I have 2 angles, I have 3 for B. And again, we show it like this. B. So in this case, you have to show this step. Remember, I just finished saying in the other case you don't, but when we're solving, we like to see it. So 180 minus A, which is 80, minus B, which is 58.2218. But I don't actually need that whole thing, but I'm going to do it anyway. So 58.2218. 180. And I still have that on my calculator. So if you follow me, I'm just going to do minus answer. I can't show you that because I don't have the camera up right now, but I'm going to do minus answer and I get 41.7782. But that is actually 42 degrees rounded. Okay? Nice. And then we only have one thing left. Again, my little summary shows this perfectly. I have to find B next, so let's go ahead and find B. But I have to decide how to do it. We actually have some choice. Okay? I know angle B, which is the contained angle, so I could use cosine law, but I have enough information to use sine law as well. So I could use either. So let's just use sine law. And so we get sine, and I'm looking for a side length now, so A over sine A equals B over sine B. And so that is little b over sine of that angle 41.7782 equals, and I'm going to use the givens here, even though I've got lots of information. So I'm going to use 21.1 over sine of 80. And in this case, no shift. It's just direct sines, 21.2 times sine of, I still have that answer on my calculator, so I'm just going to use that, divided by sine of 80. 14.3. This is my last answer, so I don't need to keep extra decimals. 14.3 exactly. So 14.3. I mean, I'm sure that that's perfect down to that decimal place. I know that it's 14.3. Still rounded, but how's that? Any questions? Okay, only one more. Start with my summary. Little l is 2.5 and little n is 3.9. So the first trick is which of the formulas are we going to use? And then which form of the formula are we going to use? What are we going to find first? Sarah, what do you think? Why? Perfect. And what are we going to find? That side length between, yeah, ln, or we call it little m, right? That's across from big M, so little m. Very good. So for little m, okay, and I'm going to let you, and I'm going to use this version, c squared equals, because I'm solving for a side length. So I'm going to let you try to do that on your own, see if you can get the right answer. All right, I got 4.3685 in the ballpark at 2.5 and 3.9, a little bit bigger, but that makes sense because the angle across from it's pretty big, 83, right? So looks good to me. Leave that number on my calculator. Now I have two things left to find, the two angles. I could find either of them. Now is when we get some choice things open up. You could use sine law or cosine law. Some teachers recommend, I don't know about require, but would say if you start with cosine law, then don't switch to sine law for the next one. And if you start with sine law, don't switch to cosine law in the next one. There's a reason for that. There's a special case that you'll learn about in grade 11 where things get a little bit wonky and don't happen the way you would expect. It won't really come up in grade 10, but doing it that way will essentially avoid you getting into that problem. I don't require it. We're going to do it now just to practice cosine law, but that is something that some people might want to try. And I'm going to give you one more tip a little bit after that will also help avoid this wonky case. Okay, so what we're going to do, what would you like to find, L or N? Angle L or Ahmed, what do you want to find? N. Okay, so we're going to find N for N. So I'm going to use cosine of C equals A squared plus B squared minus C squared over 2AB. And what do I have to remember here? If I'm finding N, what do I have to remember when I'm subbing in? Yeah. What's opposite though? So what length in this case? We're finding N. 3.9. And where does it go? Very good. So minus 3.9. As long as I do that, then make sure I do that because it's across from the angle I'm trying to find. Everything else should work out fine. Okay, continue. Plus, I'll just call this 4.4 squared, but I've got that number on my calculator. So I called it 4.4, but I'm going to use more digits to make sure I'm exactly bang on. But it'd be a pain to have to write that number out over and over and over again. So, whoops, cos C equals, and then C equals, shift, cos, bracket, bracket. 2.5 squared plus my answer squared minus 3.9 squared, close bracket divided by open bracket, 2 times 2.5 times that answer. I got 62 point, we don't even really need any decimals, but 62.4. So that was N, so 62 degrees. And then for L, I could use cosine law again, but that would be kind of overkill. What should I do? Yeah, just subtract from 180. And since we're only subtracting, you don't need those 4 decimal places. You don't really even need one. Once in a while, things get a bit wonky. If you have exactly unfortunate numbers, you can actually kind of get things wrong, but it doesn't come up very often. 35. Any questions? So the only other thing you need to know is there is a certain case that can come up that where things don't work out the way they're supposed to. It won't really be an issue for us, I don't think, in this course, but it's possible. Like if you made up your own question, it could give you a weird answer, and you'll learn about that in grade 11. But if you have a case where you're given 3 side lengths and you're using cosine law, as long as you find the biggest angle first, you should be fine. If you find one of the smaller angles, you could run into the problem. You might or you might not, and you wouldn't know it. Okay? If you find the biggest angle, it won't matter what you do next, you'll be okay. Okay? So, How do you find the biggest angle? By using the biggest side length in c squared. If you have the option, just like here, where was the example? This one. As long as you find the biggest angle first is across from the longest side, find that first and then you're fine. If you find one of the other two, you might run into some trouble. Okay?